So good morning to all the guest teachers and students. I once again welcome you to this webinar. Now let me introduce our first speaker for today, Mr. Gaurav Navangul, Volchan alumni of 2006 batch of mechanical engineering. He has also been a part of MESA team as a treasurer during his time in Volchan. He further completed his MS in mechanical engineering from the University of Cincinnati in the year of 2010. Before pursuing his masters, Mr. Gaurav has also worked at Tata Motors as assistant manager, supplier development and quality engineer. With this technical background, he also has Elite Six Sigma Black Belt and 3-year working experience at TRW. Currently, he holds the post of manager at Apple and has been at Apple for more than 7 years.
Good. Yeah. So hi, this is Gaurav. You can see the picture on the right. That's with some of my friends taken in the mechanical engineering department back in 2006. And this is my current photo, maybe a couple of years back. So I don't feel I've changed much, but maybe the photo says otherwise. So what I'm going to talk to you guys today about is overall my journey. Right now, I'm based out of San Francisco. I'm working at Apple. I'm originated from Mirrors. So I'm going to kind of take you along the journey of how I ended in San Francisco and what I've kind of learned along the way, either in the field of technical field or what kind of soft skills I've grasped along the way. So that's the thing. After that, I'll be talking a little bit about some of the career options or other choices that you guys have. You guys are living in the age of IT and in the age of internet, so a lot of this information is kind of at your fingertips, which back like 15 years back we necessarily did not have. So I just wanted to make you guys aware a little bit on what kind of things that you can do. And essentially, the world is the open playground for a lot of you guys. Then I'm going to talk a little bit about education and overall life in the US. I think Ucha did a really good job kind of walking through the campus life, walking through what kind of options we have from a research and from a master's or a PhD perspective. So I'll kind of go light on that a little bit, but I will focus a lot on, let's say, the trends and opportunities that the current industry in the US has to offer, because I've not done my PhD, I've done master's, but I've spent a lot of time in the industry. So I hope I can share some of those learnings with you, and then a little bit on soft lessons and Q&A. I'd like to see if this session can be interactive. So at any point of time, if you guys have any questions or some things that I can explain better, feel free to interrupt. So with that being said, I was I've been a Volchan alumni, BMEC, starting 2002 and completed in 2006. A couple of my highlights: I was a winner at the IIT Chennai Shastra competition as well as the COEP Fervor for a project presentation. So it was quote unquote research in a way. We developed a rotary engine which had like 4 vanes, and they were spring loaded, and it was essentially an internal combustion engine where we are trying to take the piston cylinder approach into more of a rotary fashion. So though the engine did not work, but the concept was pretty interesting. So that was a very good experience for me. After my mechanical engineering, I went to Tata Motors. So I was a GET. I don't know what GET number is going on right now, but at that time it was GET 39. I don't see about Professor Dabir on the call here, but a big kudos to him for getting Tata Motors for campus interviews back in 2006. So as a part of that, I worked in multiple departments. One of them was the quality assurance, where I was the test driver, and at that point of time, the new Tata Indica was kind of getting about to launch. This is how the Indica looked, by the way, back in 2008, 2006, 2008 timeframe. I know it looks pretty different compared to where it was in 2006. But apart from that, I worked at the body shop, which essentially is the body in white, the shell of the car that you see. And then I handled a lot of vendors, which are specifically proprietary parts like seat belts, brakes, suspension, glasses. So my journey from college, straight out of college to Tata Motors, kind of expanded my horizons, not only from a technical perspective, but also getting to know a lot of people, a lot of cultures, which typically at Walton College, let's say, for example, we wouldn't get. So working head to head with, let's say, IITians and IIM, people from IIM, it was a completely different experience. But, 2 years in, I thought I was learning, but, I thought maybe it was time for a change, time to, do something different. And at the same time, I was kind of craving to go back to school and, do some research. Maybe not so much research, but, get a break from, working full time. So I looked at different options, and what came to my mind is maybe I should try a MS, and that's how I ended up in the University of Cincinnati in Ohio. So I enrolled for my MS in mechanical engineering, but at that point of time, very honestly, I did not know what research fields existed. As I said, the internet was there, but was not as widespread as what it is now. It was still the days of Nokia 3310. I think I don't know if most of you guys probably don't recall what that model is, but for people who do, it is pretty. It's a nostalgia in time. So once I came back to Cincinnati, that's where I was able to learn a lot of things, what kind of research options are available for mechanical engineering students. There was CAD, CAM, microelectronics, there was nanotechnology, there was a lot of data analysis. There was also some of the crossover fields, which is biomedical engineering or biomechanical engineering. But I tried to go the conventional route. So I did do my master's research in computational geometry. I liked maths right from when I was small, and I thought that is a good area for me to pursue further. And at that point of time, probably 15 years ago, rapid prototyping was really coming up. And I think it is still coming up, but it was in the very, very nascent stage at that point of time. So my research was essentially working on all the backend algorithms of when we convert a CAD file to a STL file, which is a stereolithography file. When we actually do the 3D printing, how can that file be optimized? And one of the reasons for that is when we convert the CAD to STL, a lot of the surfaces are kind of they scale up to a very high degree to get a high enough
recording in progress,
able to make some really, really precise models. But what that means is it essentially increases the build time and also the cost of making those 3D printed parts. So what I came up with is a novel algorithm to take a CAD file and selectively massage those surfaces which are critical from a geometric dimensioning and tolerancing perspective. And kind of I invented an algorithm called the vertex translation algorithm to be able to take this STL file and selectively change the mesh dimensions of certain surfaces which were critical towards establishing very, very tight geometric dimensioning and tolerancing requirements for those. So I was fortunate enough to publish a couple of papers at in some journals here in the US. And then that research is still being carried out by some of my colleagues back in the lab that I used to work for the professor. At the same time, I got a good amount of exposure on metrology, which I think in Walton College we probably have some subjects which deal with a CMM or a OMM or different types of measuring instruments. So my lab essentially had a computer a CMM, which really helped me to understand the nuances and the intricacies of measurements. Because a lot of times in our college or even in India, typically the manufacturing processes always hold the higher hand when it comes to what interests people. But after coming here, I figured that the science of measurement is actually pretty critical, because any data that we use for analysis has to come from reputable and authentic sources. So working on these kind of different metrology algorithms and working
recording stopped.
Reproducibility and using statistics to actually drive some of the
recording in progress
decision making was one of the things that actually I learned a lot during my master's. At the same time, as Rucha was mentioning, there were quite a few opportunities to take courses which are not in the mechanical engineering, like electronics, or for that matter, statistics and operations research. So that actually really helped to kind of expand my vision in terms of what was possible, or where some of the mechanical engineering, or what are the facets in which mechanical, statistics, and multidisciplinary applications could kind of coexist. And that kind of opened my eyes in very different ways. At the same time, I was fortunate enough to get like full scholarship during my 2 years at the university. But at the same time, I worked as a research
Recording stopped.
Procter and Gamble. I think you guys probably know most of the consumer.
Recording in progress.
Most of the consumer items that we see in the market, be it diapers or toothpaste, a lot of things come from the parent company, Procter and Gamble, because they're essentially headquartered in Cincinnati. So we had a lot of research, a lot of funding, a lot of projects from Procter and Gamble back in the university. So I helped them design an equipment to be able to make diapers that are used for obviously for children, to redesign them for cost and sustainability. So that was a very big project in terms of the reach, because whatever we were designing, they were about to kind of scale it to multiple locations across the globe, like a lot of locations within the US, Brazil, China. So it helped me. That was my first experience kind of working with people from different cultures, which have different set of expectations, different set of rules. But one thing that was still common for all the people from people across the globe was the desire to excel and the desire to make best of the opportunity that they have. So that was
Recording stopped.
Me from the perspective of completing my master's. At the same time, there are some things that I've not written here, but going back to university, it helped me to kind of
Recording in progress.
reevaluate what I wanted to do in terms of my career forward, because as Rucha said, you typically have an option of continuing on to a PhD, which I had an option as well, but I chose more to go into the industry because for me, I thought applying a lot of this knowledge and kind of applying it to businesses to really excel and to grow was kind of my passion. So that actually really helped me to understand and clarify the vision in my mind. I did not want to go into the field of research, but I wanted to go into the industry. So that was like a stepping stone for me to go into my first job in the US. And boom, I landed up in Peoria, which is in the state of Illinois. I try to make these visuals with respect to the map, so you also get a good understanding of the geography of the United States and why some of the clusters in the country belong to certain industries. So you guys probably already heard about Caterpillar. It's a heavy duty engine manufacturer, a lot of earth moving equipments, a lot of big engines that go into submarines and some Navy and other Army applications as well. But this particular assignment for me was more in the heavy duty engine design department, which we used to make and design engines that go into large ships. The ships that carry like hundreds and thousands of tons of material. So it was a very different design and exploration solution space for me, because even while being worked at Tata Motors, it was very miniature compared to the exposure I had in engine design back in Caterpillar. So a lot of my knowledge and a lot of the experience in CAD/CAM that I had gathered over back my master's, it was kind of something that was directly useful while I was working at Caterpillar. The other thing I did is a lot of system integration. So essentially, you have a fuel filter, you have flywheels, you have gears, you have the engine block. How do all of them come together, and how can we package it in a given volume at the same time not exceeding some of the hard stops that we have in terms of performance or in terms of packaging, in terms of weight. So I think in a way it was more like a multi-factor optimization problem, where you've been given a certain set of conditions that you cannot exceed, and you have to optimize the function over and over and over again. So it meant working with a lot of experts in the fields of FEA, in the experts in the field of CFD, thermal sciences, mechanics. So overall, that helped me to kind of understand some of the nuances of how product development actually happens in the real sense of term. After that, I decided to do something different. I got a better job opportunity, and I moved to the automotive capital of the US, which is Detroit. That's where Ford, General Motors, Chrysler, a lot of these companies are kind of headquartered at. So I chose a tier 1 supplier for a lot of these OEMs, specializing in steering systems. So at that point of time, this job asked me to be a subject matter expert for metrology with all my prior knowledge and experience back in the university. So if you see on the right, it's called a rack and a ball nut, which essentially is a mechanism that drives your steering. So when you are essentially turning your steering, it gives pulses to an electric motor, and this is the mechanism that actually pushes the rack, which is the green bar that you see, and helps to drive the wheels. It's pretty simple, right? But one of the major complexity of this was the noise, vibration, and harshness. Maybe some of the roads in Asia, that doesn't matter much because there is a lot of ambient noise. But when the roads are really good, the steering system needs to be really quiet. Particularly now that a lot of electric vehicles are coming, there is absolutely no noise from the engine. So how do you minimize the noise that is coming from the steering to make it a high quality vehicle? So one of my projects and something that I was kind of researching while being at TRW was how do some of the mechanical surface finish waviness related properties on all these components of the recirculating balls in the rack, the ball nut, in the motor, how do they directly influence noise, vibration, and harshness characteristics, and kind of establish a direct correlation between some of these inputs that actually drive the final output of what a user experiences when user drives the car. So initially I started in this company as a product design engineer. So I used to model all these racks and ball nuts and steering systems day in and day out, work on a lot of drawings. But then I figured there is a lot of exploration that needs to be and that needs to happen in the field of data. And that's how I encountered some of the experts who were like master Six Sigma belts, Six Sigma black belts, and I was able to get my Six Sigma black belt while I was working at TRW. Obviously, you guys probably are already familiar with Six Sigma, but a lot of it is also about how do you apply some of those principles to problems. And once I completed my first project, it kind of opened my eyes in terms of how can metrology, statistics, core domain experience in certain mechanical systems come together to solve really complex problems in the industry. So that was back in 2014, which was still like 7 years back. And very honestly, I don't quite recall what 2014 looked like because now it's 2021. But then one fine day, I got a call from Apple, and they asked me if I was willing to come down to West Coast and work for Apple. And at that point of time, I did not know what Apple actually did, right, from a mechanical engineering perspective. Because in my mind, Apple was still very much a tech company, a lot of software, a lot of IT. But I was quite pleasantly surprised to know there is a lot of mechanical engineers that work at Apple to make these beautiful products. So I came here to Cupertino, which is the headquarters of Apple. What you see on the top is the office I work on. It's the Apple spaceship. You guys probably already saw this somewhere in the media. It's a piece of art. But right now, what I'm doing is I'm working on the iPad. A lot of the mechanical parts that go into the iPad, the Apple Pencil, and then a lot of the other mechanical parts that go into making the iPad. So a lot of my current responsibilities are around product development, but I specialize more into the manufacturing and quality operations of all these mechanical components. As I said earlier, this is a peculiar role in which statistics, metrology, a lot of data, machine learning kind of come together. As you can imagine, we make a lot of iPads, for example, but there is a lot of data that comes with manufacturing these from different sources, different factories. So how do we take all that information, drive trends, and use those trends and analysis to actually drive further improvements and provide feedback into next generation of products? So that's the area that my team actually excels in. Apart from that, I work and oversee a lot of very smart people who are kind of subject matter experts in their fields when it comes to statistics, machine learning, a lot of machining processes like sandblasting, CNC, a lot of joining applications, which are pretty secretive in nature, to say the least. So overall, of all the experiences I've had in my career since I graduated from Walchen, this is one of the most immersive experiences for me when it comes to applying all these skills. But at the same time, being very close to mechanical engineering. But what really takes it apart is the fact that the work that I'm able to do actually touching a lot of or millions of people in different parts of the world. So that's been a very satisfying aspect for me for the last few years, and that's one of the areas that I'd like to share with you guys. So long story short, that's how I ended up in San Francisco. So this was all about me, but maybe now we can talk a little bit about you guys and what you want to do. I think Rucha covered a lot of it in terms of what options you have, but I'd like to still maybe share a few other things. When you get out of college, you have good jobs. The other day, Dabir sir was telling me that some of the pay packages in as a GET in India have skyrocketed pretty high, which is actually really good. But at the same time, there is still an opportunity for cross streaming. Obviously, MS and PhD is the way to go. The cross streaming is one of the important is an interesting idea, because a lot of times when we are in bachelor's, we keep thinking right now when it comes to MS and PhD options. If you want to develop your business acumen, a US MBA is a really highly rated program overall. Obviously, there are going to be different types of MBA colleges, some low rankings, high rankings, but it's a good area to be in if you want to expand on your operations and the business side of the knowledge base. The third thing I would say is, if you want to change the field, you're a mechanical engineer, but no, you like something different, you like aviation or you like filmmaking. US very much encourages those kind of transition profiles, even though those are, I would say, not completely popular for students that go out of India, but it is not uncommon for students that come from other countries. I think Rucha gave example of students from different countries like China, Europe, Africa. A lot of the people, a lot of those students do engage in kind of changing the fields from where their initial bachelor's degree was. So that's an area you guys can think of, but some of the things, it also probably comes with some negatives in terms of the cost of the education, the opportunities and things like that, but it's an option that is available. And then lastly, if none of these work, obviously there is entrepreneurship. It's a leap of faith to a certain degree, but it's definitely something that is on the card for.
Recording stopped.
I know there is a lot of startup culture that is going on in India. So
recording in progress.
So I think the best kind of learning that you can have is kind of on the job. So and being an entrepreneur or even being in a startup gives you that option of learning a lot and going into a lot of depth. But if you stick to the first two options of, or first three options of pursuing a master's in the US, some of the things that you are definitely going to encounter is overall a 30,000 feet view of the world. Obviously, you have to take a flight to the US, so you're in an airplane, but otherwise, some of the things that you took for granted, or some of the things that you thought were like in the world, when you go to a different country, you experience all those things in a completely different fashion. So that's one of the experiences that I have very close to my heart. Diversity is the other one. People from different backgrounds, from different cultures. It kind of really opens up new experiences, and you're able to get a lot of new friends, which are obviously not Indians, and that experience is very enriching.
Recording stopped.
Going out of comfort zone is another critical.
Recording in progress.
Yeah, going out of comfort zone is another critical aspect that I would like to emphasize, because every time there is a change, you are going out of your comfort zone, but that also means a lot of opportunity. So those two words are pretty loaded when it comes to taking the decision of leaving a good paying job in India and going and trying something different. And lastly, I would say influencing, because essentially you are influencing yourself to a certain extent.
Recording stopped.
Also could benefit the rest of the world. Like who knows, between a bunch of you guys, there might be a CEO of a really big company. So those are the factors, and those are some of the things that you should probably consider. But again, first things first, I think from a prerequisite standpoint, I think Rucha covered a lot in terms of the finances, what kind of scenarios you would encounter when you go to the US, because there won't be any salary for, let's say, for the first year or so, but you have a lot of living expenses. The US is expensive, so I think she did a good job of covering, depending on what area of the US you are, the amount of money that you spend for living expenses, for tuition, for all these other things vary quite a lot. So a good analysis in that respect would be really beneficial. Documents is one thing I would emphasize, is because particularly for finances, there is a lot of paperwork that is required, particularly if you don't have a scholarship. So I would engage on that and start looking at those right from the get-go. I cannot emphasize this more, but and again, you guys are all smart because you're from Walchand. Excellent scores go a long way in terms of getting really good admits from good universities. Particularly, I think right now we have GPAs, but that's something I would emphasize, particularly for, let's say, first year or second year students who are still trying to get a hang of things. I would encourage them to really take that a notch up when it comes to academics. The other thing is a lot of extracurricular activities and research that can be done while you're in the college. I think paper presentations are one of the good ways of doing this. But back to what Rucha said, some of the superficial things that we do in paper presentations kind of doesn't work in the US. So some core fundamental research, particularly look for some tie-ups with some of the professors from international universities, which could be more like a joint research. That would actually go a long way in terms of getting your resume and profile noticed when it comes to for the professors to select the different students to give admits. So that's an area I would emphasize. And then the other thing is figuring out which exam you have to give. Either it's a GRE, a GMAT, a SAT, a TOEFL. I think we talked a lot about this, but again, I think the high scores in these exams are pretty important as well. Lastly, I think the deadlines are one of the things that I would like to emphasize, because particularly in my case, I did lose out on some universities because I did not conform to the deadlines of application. So I would encourage you guys to go in deep on whichever universities you decide to go, and to figure out what their application process looks like, what kind of documents you need. Look at the university syllabus and see if that matches what you are roughly looking for. As I said, back in 2006, the internet was still new in India and not a lot of things happening. So for me, until I landed at the University of Cincinnati, I did not have a very good idea on what I was going to do from a research perspective, but now the things have changed. Definitely talk to the students that are already in some of those universities, either through LinkedIn, or there are a lot of forums that for those universities, or there is a lot of groups like the Indian Student Association that you can reach out to and try to get a lot of information. I also know there are some academies, like I think the Dilip Academy in Pune is pretty famous for getting some of that information out to students before they even start applying. So I would maybe recommend to take that route as well as required. So we are all engineers, so I would like to maybe talk a little bit more about the factors that drive the university selection. And some of this, what I'm trying to show you, is purely from a master's perspective. As Rucha mentioned, for PhD, the dynamics are different because the probability of getting a scholarship or getting employment as a research engineer are pretty high. But from a master's perspective, I think the quality of a university or the rating actually depends quite a lot on how high of scores you have for GRE, TOEFL, or academic, and that's why you see a direct linear correlation between those two. The same thing goes with cost. Typically, high quality university means the costs are expensive. If you take examples of universities like Stanford or MIT or Harvard, they're typically in the 50,000 to 100K per year range, which is pretty high. And then the same thing goes with probability of scholarship as well. As the university rankings are higher nowadays, scholarships are a little hard to come by because of all the federal funding that has been reduced by the government. But with that being said, there is still scholarship that comes from industry because, like I mentioned, in the case of University of Cincinnati, Procter & Gamble was an active sponsor for a lot of the research projects. So that's why the next slide that I'm going to go to is more in line of which universities to pick from and from which industry clusters, because you ideally want to pick a university which is, let's say, in a certain industry cluster that you're looking to base your career off. Probably has higher chances of scholarship, but at the same time, you get to know, or you get to do what you actually want to do. So I would say a happy mean here would be looking at an optimal point where the quality of university is still in the higher end of the spectrum, but at the same time the costs are kind of balanced with a 1:74 ratio of dollar to rupee. So that would be one good consideration. The other thing is, even for masters, you could still get a scholarship. You could still get a job as a research engineer while working for a professor once you land in the US. But until then, some of those things are a little uncertain while you're in India. Actually, that was one of the decisions why I chose the University of Cincinnati, because I got a full tuition waiver. I did not have a job back in India, but when I landed, when I talked to my professor, I was able to get a job while I was studying. But there were some other better admits that I got, like from University of Michigan, Ann Arbor, Michigan Tech. But again, those universities did not offer any scholarship, though their ratings were high. But I had to turn them down because I did not want to take on the liability of additional loan, or going through some of the tuition and fees. Apart from that, I think the other factor, and I think this is a pretty critical factor, is the weather, because the weather can get really crazy in the US. So these are the pictures of two different universities at the same time in winter. So Howard University is in Boston, in the northeast corner of the country, which gets a lot of snow, and that's how it looks. And then Stanford here is in California. So you can clearly see differences. Obviously, they come with some cost, or a higher standard of living in Stanford versus, let's say, Howard, because of the dynamics of that geography. But if you're a person who doesn't like cold weather, that would be one area to consider. The other factor I would say is be close to family, friends. If you have any in the US, that kind of goes a long way in kind of getting some emotional support, or if there are things when you need some help, there people can be around you. At the same time, if a bunch of you are kind of applying to similar fields, you could probably tag team and go together. I think that helps a lot, particularly when it comes to being homesick. One other factor which I've not included here, and you guys should probably be aware of it, is the whole debate about immigration. Nowadays, with all the legislation that is going on with the new presidents, green cards and getting work visas is increasingly difficult to come by. But with that being said, the master's in engineering does qualify for a specialty occupation. So it's still in a good shape, but that's one other area to consider while you pick which particular field you want to specialize in. So as I said earlier, just to give you an overview of, this is the map of the United States. If we have to focus or divide it by the different industry that is spread out across the US, these two blocks here, they are essentially called the Midwest, and they specialize a lot in the heavy machinery, like big giants like Caterpillar or John Deere, or for that matter, Cummins. All of them are kind of located in this belt. The middle belt is the automotive, consumer goods and manufacturing, with the likes of all the automotive OEMs. Kentucky and Tennessee is more about manufacturing for all the automotives, and Michigan is where a lot of the research and development for automobiles take place. On the East Coast is a lot of finance, biomedical, government agencies, steel, glass. A lot of those industries are based out of the East Coast. The top, North Dakota and South Dakota, honestly, you don't want to be there because the temperatures are really, really cold there. But that's where a lot of oil and mining industries are located. And so also on the south, which is kind of rich in oil and gas. So companies like Schlumberger or ExxonMobil, all of these companies are located on the southern side, which kind of deal with exploration. But that exploration also means there are a lot of mechanical components that are required to enable that. So there are a lot of industries that actually make these heavy machinery back there. The middle part of the United States is a lot about food, dairy, and agro. So a lot of food industries, meat processing, agro industries, like things like tractors or farm equipment. A lot of these industries are based in the middle belt of the United States. And then if you move to West Coast, The Seattle area is famous for aviation. It's like Boeing is headquartered in Seattle. There's a lot of semiconductors like Intel, a lot of other tech companies. Amazon is based out of Seattle. So a lot of opportunities when it comes to some crossover fields, particularly for mechanical engineers. And finally, California, I think that's the other area where there's a lot of computers, tech, Silicon Valley, companies like Apple, Google, Facebook, Tesla, you name all of them are, essentially in California. So that's kind of the lay of the land in terms of what US has to offer from an industry's perspective. What this also means is all the universities that are there in these specific areas kind of cater to the industry, what the industry requires in terms of research. So if you have to kind of excel in automotive industry, I would pick Michigan, because that's where a lot of something to do with software or machine learning. I would pick California, because that's where most of the new developments are happening. If it has to be oil, if you're thinking about joining say Schlumberger in India and then doing something in the field of oil and gas exploration, I would pick University of Texas, for example, in the south of the country. So this is like I would say a cheat sheet, but that doesn't mean that tech companies don't exist in the East Coast. They still exist, but the amount of people or the amount of industries, the density of the industries for those particular fields are going to be much higher in these blocks. So I think this is another consideration, depending on which area interests you, to pick a university that is kind of catering to the natural resources in that area as well as the industry in that area. Moving on, I think just to maybe summarize, from opportunities perspective, there are a lot of new startups coming up in the US. So this is essentially, we are at a stage now when you've completed your master's and now you're looking for jobs and looking for opportunities. So those are some of the categories that I'm hoping to go through. With startups, you really get an end-to-end experience of from what we call as a cradle to grave experience for a product development. Cradle being you're trying to think about a product. You're trying to design it, you're trying to analyze it, cost it out, manufacture it, and sell it, right? So it's an end-to-end experience. That's what you typically get in startups, because there are less number of people. The products are very focused. The teams are small. So it's something that is very popular right now in the US. Apart from that, the electric vehicles there's a big boom for electric vehicles. Like pretty much every OEM is transitioning to electric vehicles by 2025, if not 2023 or 2030. So, and a lot of component manufacturing that goes along with it, particularly battery technology, is really picking up. The goal being, how can we maximize the efficiency of battery without sacrificing the surface area and the volume and the weight to make the electric vehicles lighter. So that's a very big field that's kind of coming into picture. There is a lot of autonomous driving right now on the streets of California. Here we see a lot of autonomous driving where there are no drivers, the cars kind of going by themselves. There's Waymo, Zoox, Cruise, all of these companies always looking for mechanical engineers who have rich experience in controls. So that's a pretty big space. There's aerospace, but with aerospace there are some limitations when it comes to being citizen of the US or having a green card. So there are some limitations up to on which what a non-immigrant can contribute when it comes to the field of aerospace. Apart from that, there is consumer electronics, obviously Apple, Intel. There is software and control system engineer. Biomedical industry is pretty big with all. I think Apple the US is actually leading leading country which develops and manufactures a lot of high-tech biomedical industry, so quite a few opportunities there. And then there is also technical consulting, which is a lot of engineering services, be it related to CAD, CAE, expansion, setting up new manufacturing lines. So there are a lot of companies which do a lot of technical consulting, which still need a lot of technical experience, but they are more project or more business focused. And then lastly, there is advisory and consulting. There is Deloitte, PwC. I've seen a lot of mechanical engineers go to banking by the virtue of statistics. There is a lot of data scientists and machine learning related opportunities. My team right now, we have a couple of machine learning engineers who have similar backgrounds, who are mechanical engineers, but they've done a lot of advanced education in machine learning, kind of helping to bridge the gap between what typical mechanical engineering industries get from a data standpoint and putting them in the form of trends that can be used for efficiency improvement. And then there is environment and sustainability. This is a pretty big area that is coming up because as you know, with all the climate change and a lot of the earth saving initiatives, a lot of these environment and sustainability companies are directly contracting with a lot of big companies to overall reduce the global carbon footprint. So recently I was checking a few universities, and environmental sustainability is actually, some universities have dedicated departments, and a lot of active research is going on in those areas. And then lastly, oil and gas exploration that I briefly alluded to. But what this all means related to the skills you have is still the same. So, I mean, if you're a mechanical engineer going into technical field, CAD, CAM, CAE, FEA, machine learning, advanced statistics, CFD, digital signal processing, modeling and simulation, advanced manufacturing engineering in terms of rapid prototyping, could be CNC, could be polytrusion. All of these are still very critical towards being successful in getting jobs in any of those categories. Lastly, to mention geometric dimensioning and tolerancing, which is still the base of any mechanical engineering component, and then so also the metrology. So even though all of these categories exist, the skills that drive some of these industries are still the same. So that's why I would really like you guys to see where you want to be in terms of specializing in your universities, what kind of categories of jobs would entice you going forward, and then pick the courses and skill sets that kind of meet those categories. So I would not say this is like a cheat sheet, but I would encourage you guys to make something similar that you can actually review and help shortlist and down select the different areas that you're thinking from the perspective of education. So that's all about the universities and the courses. Some of the soft lessons that I kind of learned over the last few years, being in the US or during my experience in India. I think Rucha alluded to it about, I'm strong technically, but I don't need communication skills. I think that's where a lot of our opportunities exist, particularly, coming from India, we still speak good English, but there is still opportunity for better communication in terms of relaying and communicating what we want to communicate effectively. So this is one of the things that a lot of companies practice, which is the elevator pitch. So imagine you're in an elevator with the CEO of the company and you have a great business idea, but the CEO only has 20-30 seconds to spare while the elevator is going from the the bottom floor to the top floor. So how can you pitch the entire concept to the CEO in 30 seconds so that you can impress him and get him on the same page and get a go ahead for your project? So again, this is not applicable to every particular scenario, but in a lot of the scenarios, how can you better storytell, be it technical story, be it a business story? So that's one area that in the US is sorry, somebody had a question. Okay. If not, the next one, work hard, but be smart and impact driven. That's actually always keep an eye towards where the goal is or what the final mission is, but also be smart about it. Like sometimes, I mean, most of the innovation sometimes happen with people who are really lazy. But again, that's a virtue in a way, because then you are actually improving the efficiency of what you're trying to do. Presenting, packaging, and marketing your work, because particularly when you're in the industry, you could really do a lot of work, but how do you present it, package it, and market it to the people who actually are the decision makers? And when it comes to that, the technical acumen or the technical information and technical knowledge is not good enough. You need to connect that technical ability and the technical information to what it means for the business, what it means for growth. So those are the areas I think there is quite a few opportunities for that myself included we all can work on. Lastly, be respectful, inclusive, and open-minded. This is a famous quote from Albert Einstein. More the knowledge, less the ego, because you know a lot more things and you know how things work. And less the knowledge means more ego. So when it comes to working together with diverse people from different countries, from different backgrounds, it is actually very, very critical. at the same time, take calculated risk and always, seek discomfort, because that's how you will grow. With change comes an opportunity, and with opportunity comes growth. So there have been a lot of times in my career, or when I came for my master's, where I was very comfortable in the position that I was, be it financially, because maybe my expectations were not that high, or it was good life, but I decided to seek discomfort and do something different, to challenge me and to go into that territory where I could grow. But that came with discomfort. So don't feel afraid to take risk. Take the calculated risk, and the luck will help you at the end of the day. So that's all I had. Hope it was not like a fatherly lesson here, but I thought I would share some of my experiences, which I thought were kind of useful for you guys.